All right, hello people that are watching this video. This is 4-4. This is going to be like the first probably half, maybe. We'll see how far we get, of 4-4 rational functions. Okay, so let's talk about rational, like what makes a function a rational function. Up to this point, we've been dealing with polynomial functions, right? I'm going to go back. Okay, so I'm going to put, you don't have to write this down, but I'm going to talk about polynomials. Polys would be like linear and quadratic, and then cubic, and quartic, and quintic, and all those things, right? Like x to the fourth, blah, 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 x to the third, blah, 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 x squared, blah, 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 x, blah, 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 right? All of those things, those are all polynomials, okay? Rational functions are polynomials that occur in the top and the bottom, okay? So you have like fractions and polynomials on the top and the bottom of your fractions. So this is a polynomial technically because the x is a polynomial on the bottom. This is a polynomial or a rational function because a polynomial on the top and a polynomial on the bottom. This is linear on the top and linear on the bottom. This third one is cubic on the top and quadratic on the bottom. Okay, so it has, in order to be a rational function, it has to have stuff on the top and stuff on the bottom. Okay, the graphs of these are really ugly. Like 1 over x. Put this down on your paper. 1 over x, the graph of him. That's the parent function for this guy. Those are like the boomerangy equations, right? Where they have vertical asymptotes and stuff, okay? So they have like vertical asymptotes, horizontal asymptotes. That's what this section is about. Is talking about like the Vaz and Haas and like problems that occur. Polynomial functions are nice. They don't have any holes. Or they don't have any vertical asymptotes or anything like that. Rational functions are not so nice. They do have like weird parts of the graph, okay? So we're going to talk about domain first. That's number one. Number one thing is domain. I'm going to put that off to the side so when they're asking for domain on your homework assignment, you can find it really easy. Domain is over here. Find the domain of each function, okay? Domain is x's, like what can x be and what can x not be. So like in A, the two things that screw up domain are a negative inside of a square root and dividing by 0, right? We don't have to worry about a negative inside of a square root for any of these. We're only worried about dividing by 0. We don't ever want to do that, okay? So if I look at this first one, I don't want to have 0 in the bottom. I don't want to have 0 in the bottom. Shh, your boys. So what can x not be for my domain? X can't be 0, right? If you can't figure that out in your head, like we know that x squared can't be 0. And if I take the square root of 0 is 0. So x can't be 0. That's my domain. It can be any other number except 0 because if I plug 0 in, I'll end up dividing by 0. And that violates domain. So that's the domain. Now, domain is very closely related to where the Vaz are. Put that down. Where the Vaz are. Okay? So, for domain, like if we talk about domain of this one, 1 over x. Domain of 1 over x, x can't be 0, agreed? Because what happens at 1 over, at 0?
You can't divide by 0.
You can't divide by 0, right? But if the domain can't be 0, what's happening at 0?
It's a vertical asymptote.
It's a vertical asymptote. So, the domain, where the domain poops out, like where x can't be, where it poops out is where the Vaz are. There's a vertical asymptote there. That's why he's not touching. That's why x can't be there, because there's a Va there, right? Does that make sense? Domain and Vaz are just like the same thing, right? Like where the domain fails is where the Va happens, okay? B. Ooh, we don't want to ever divide by 0. So I'm going to worry about this denominator, okay? But he can break down. He's a simple trinomial. What can you multiply to get -6, but when you add them, give you -1? Shh, boys. Shh. Multiply to get -6, add to get -1. What do you got? Multiply to get -6, add to get -3 positive 2. Got it. Okay, so if that's how that breaks down, what can my x's not be?
3, -2.
X can't be 3 and x can't be -2 because I switched the signs of those, all right? If x was 3 and I plugged 3 in here, I would end up getting 0 right here, and that's bad, right? Or if x was -2 and I plugged -2 in there, this whole thing would end up being 0, and that's bad. I don't ever want 0 on the bottom. So my domain is that x equals or x can't be negative, x it can't be 3 and x can't be negative 2 because what is happening at those two places? That's where your VA is. That's where your vertical asymptote is. Exactly. Okay? Good? Makes sense? C. Okay. All right. So, next thing we're going to talk about is intercepts. And more specifically, I think they're going to ask for the x-intercepts. Find, we'll do x-intercepts over here. X-intercept.
How far are we going today?
We'll do y-intercepts also. Probably to the bottom of the page, maybe. We'll see. Y-intercept. We'll do x-intercept, y-intercept. Okay. Do you remember how to find intercepts or like your zeros or like where it crosses?
Not really.
X-intercept. Okay? So like the way that I think about this is, here are some x-intercepts. Here's some examples of x-intercepts. Like this is the point like 1, 0. This is the point 3, 0. This is the point negative 2, 0. This is the point negative 5, 0. What do all those x-intercepts have in common? The y equals 0, right? So if I'm trying to find x-intercepts, I plug 0 in for y. Same thing goes the other direction. If I'm trying to find the y-intercepts, I plug 0 in for x, right? So that's how you find intercepts, is you plug 0 in for the opposite one, yeah? Okay, let's do y-intercept first because that's easier. If I plug 0 in for all of the x's, I have 0 squared minus 0 minus 2 over 0 minus 1. Okay? All of that stuff on the top becomes just negative 2. All the stuff on the bottom is negative 1. So my y-intercept is 2. You see that? Positive 2?
Yeah.
Go over to the graph on the right, on the left side. Is it intersecting the y-axis at a positive 2?
Yes.
Yes. Okay, great. The x-intercept, put your hand up. I'll answer it in a minute. Okay? I'm going to plug 0 in for y. So 0 goes here. And this one's a little bit more complicated. I'm trying to solve for x, or get x by itself when I set 0 equal to y. So what can we do first? I'm going to multiply by x minus 1 over to the other side, right? Multiply by x minus 1. Okay, but, yay, that's exciting. X minus 1 times 0 is just 0, right? 0 equals x squared minus x minus 2. Okay, now what can we do?
Add 2.
I don't want to add the 2. I want to break it down.
Oh.
He's a simple trinomial, right?
Yeah.
So what can you multiply to get negative 2, but when you add them give you negative 1? Negative 2, positive 1. Okay, so if I set those equal to 0 then, x minus 2 equals 0, so x equals positive 2, and x equals negative 1. Those are my two zeros. Is it touching the x-axis at negative 2 and or negative 1 and positive 2? Yeah, right here. Negative 1, positive 2, and positive 2 on the y-axis. Yep. Those are my x-intercepts. Okay? Now, the really nice thing is that the y-intercepts you plug 0 in for x, but every single time when you're finding the y-intercepts, this is what will happen. Are you ready? This is going to make life a little easier if you can remember this. Every time you're finding the x-intercepts, you put 0 here. And every single time, this bottom, when you multiply it over, goes away. Right? Because it's going to multiply to the other side. So all you have to worry about is setting this equal to 0. So if you can remember that, you can skip like a step, right? Like the top is just being set equal to 0. That's all you have to worry about. Okay? All right, so I'm going to put this over here. This is number 2. So in addition to domain, these are the x-intercepts and the y-intercepts. So if they ask for that in your homework assignment, you know where to look. Back to this example. Okay? X-intercepts, y-intercepts. There it is. Okay, I'm not going to talk about big little concept. We'll do that maybe sometime. Okay? I don't know that I want to talk about example 3 either. Let's do, because we've already talked about vertical asymptotes really quick, let's do the top of the next page. Okay? Vertical asymptotes, top of the next page, real quick. And I'm going to do a couple of examples, and then we'll be done. Okay? So, this is number 3. This is vertical asymptotes, or VAs is what I will call them. Vertical asymptotes. Vertical asymptotes. I'm going to do a couple of examples. Example. We'll do 3 examples. They're really fast and short. Okay? Let's say I have 3 over x. Okay? Let's say I have negative 2 over x minus 4. And let's say I have 5 over 2x plus 1. Okay? Let's say I have those. Okay? When you're trying to find the vertical asymptotes, it's where the domain poops out, right? And so I'm going to say opposite of domain. When we're analyzing or finding the domain, we're setting the denominator, D-E-N-O-M, not equal to 0, right? Like we don't want the bottom to be 0. Okay, so if I'm looking at domain for that first example, example 1, 3 over x, what can x not be? 0. X can't be 0, right? I don't want 0 plugged in for that spot. So that means a va occurs at x equals 0, right? The domain can't be 0 because that's where a va is, at x equals 0, okay? What that will look like is x equals 0 is this dotted line right here. That means he has a va right there, okay? Example 2, let's talk about domain because it's easier to do domain first. What can x not be for number 2?
4.
X can't be 4 because the va is at x equals 4, okay? What that will look like is 4 over here, and that's where your va is, right? That's where it separates the graph, okay? All right, now this one you can't, maybe you can do in your head, maybe you can't. Domain and va. Okay, what's the domain, or what can x not be in the third example?
-1/2.
Can you do that in your head? Yeah. If you can't do that in your head, 2x plus 1 can't be 0, right? Subtract the 1 over, 2x can't be -1, and divide by 2. So x can't be -1/2. Okay, some of you guys can do that in your head, great. That's because a va is happening at x equals -1/2. So when you're finding the va, it's like the opposite of domain, right? A va at -1/2 would be like, here's 1, -1/2 is right there, okay? That's what he would look like when we start to put the graphs together. All right, so domain, x and y intercepts, vas. You got a couple of them probably that you can do on your homework assignment. Yeah, you've got a couple that you can do on your homework assignment. We'll talk about holes later. We'll start on those on tomorrow. Okay, good? Okay, goodbye people watching this video.